of the software industry and currently the Director of Training at WANdisco. Mike began his career in computers when people used mainframes and when bytes were measured in thousands rather than trillions. After programming in everything from assembler to SQL, he began specializing in training and consulting on such diverse topics as configuration management and data design. For the past 3 years, he has been developing training for WANdisco, as well as speaking on a variety of technical topics. I'll now hand it over to off to Mike Lester.
Thank you. Thank you, Jen. Let's forward this. This webinar is our first introduction to Git, and it's also our first introduction to talking about Git as a company. And one thing we want to make perfectly clear here is this is a 40 to 45 minute overview of Git for people who pretty much haven't used it before. Like any sort of product, there's hours and hours of instruction, and we have to start somewhere. So what we're going to cover today is give you information on how you get into Git and how you can do that from either command line or GUI, a little bit about the repository, the local repository, and how you create it and how you add things to it. We're going to go through the simple exercise of doing checkouts and commits back into that local repository. Then we're going to show how to do branching and how to take the changes you've made in your branch and merge them back into your master branch in your local repository. Now with Git, you tend to have local repositories and remote repositories. The remote repositories are sort of where everyone gets their information from to populate their local repositories, and that's a command where you will pull information and populate your local repositories. After making changes, at some point you will take the changes you've made and push them back to the remote repository. But in this session, we're really going to be just talking about that local repository, the one you set up and control all by yourself. Possibly in later sessions, we'll talk more about moving information to and from that remote repository. Now, to use Git, you have to initiate it. And to initiate a new repository, you have to be in Git to do that. And there's a number of different ways to initiate Git. I'm using a Windows computer, so I'm doing it under something called Bash. We'll show that in a second. And you can do that by either typing in the line that's shown here on the top, or, and quite frankly easier, if once you install Git, you will have a icon that you can click on, and that will start that up for you. Now, initiating a repository couldn't be easier. The first thing you have to do is make a location for it, and then go to that location, and that's where you will initiate your repository. And it will have a name based on its location. And you can have any number of repositories on your local machine. We tend to have different repositories for different uses. The git space init command is what we use to initiate our repository. In addition to doing it from command line or the git bash, you can also do it from a GUI. Now there's a number of different GUIs out there that you can install, and these are like the different clients that you would use with something, for instance, like Subversion. Tortoise SVN is just one of the clients you can use to get to Subversion, and this one here, Git GUI, is just one of the clients you can use with Git. And this is open source also, just like Git is open source. To create a new repository, you just fire up the GUI and then select Create New Repository and specify where you want that repository to be related. You can create a repository in command line and use it from GUI or vice versa. It doesn't matter. we're going to be mainly talking about command line and executing the commands from command line, but from time to time we'll also show using the GUI tool, this particular GUI tool. Keep in mind there are others. When you fire up the GUI tool, you specify which repository you're going to use, and then it shows you information about that repository. And we'll show you different examples as we go through adding files to the working area, moving them to the staged area, and creating history as you commit them into the repository. Now, one of the things we're going to be doing often is checking this working area, and it's called the working tree area or the working tree in Git. And what I initially am going to do, especially when I show the demonstration portion of using a local repository, is I'm going to create a number of different files. Here we created files in a folder and a file in that folder. Then we ran the list command to see that they existed, and then we took the information from the list command and put it into one of the files, and then we listed out the contents of that file with a cat command. Well, once I've put that in my working area, my working tree, if I run the status command, it would show me information about that working tree. Now, the status command is the same as a lot of other version control tools, such as Subversion, where it shows you the status of your working folder. And here it's saying that we have a folder and 3 files that are in our working tree that are untracked. One thing nice about Git is if you run these commands in sort of a verbose mode, it will, as comments, show you information and also show you what the next command might likely be. For here it says use git space add and a file name to include this in what would be committed. When you add a new file to your working area, it's not going to be part of your next commit unless you run the add command, which says you want this particular file to be under version control. Now, these untracked files here will be any files that you have in your working tree that you haven't specifically said through configuration that is of a type you want excluded. So here we are actually running the status command. In the status command, there's many different options that you can have for the status command. One that I use frequently is the -s, which I think of as short, and it presents the same information but sort of in a shortened format. And what these question marks mean here is that here are 4 things, a folder and 3 files, that are in my working tree, but I haven't added them to version control yet. And it comes up with this question mark. The same information can be seen in the GUI environment because these are considered what they call unstaged changes. We haven't added them to version control yet, nor have we said we want these changes to be part of the next commit. Once we've added them to version control, then they would move from here down to the staged changes. But it doesn't make any difference whether you run this from command line or from GUI. The same information's there. It's just one of them's textual and one of them's GUI. So you can use whichever one you want. Here we have both the GUI and the command line pointed to the same repository. So the next step we would do in this scenario here is we would decide to add all or some of the files to version control. And you can run the git add command against a single file, which we did here, and then when we run the status command, you can see that there's an A has replaced these 2 question marks. And what that A says is that if I did a commit now, test 2.0 would be added to the repository, and these others wouldn't be. You can run the add command with a dot, which says take everything that's within this folder and add it to version control. Now, if you ever can't remember all the various options that you can use, there is a help option where you can put in the verb, the command, get, add would be the verb or the command here, and -help to give you more information about the different options of the add command. Now, how this shows up will be controlled by your configuration. It can either come in a textual manner here, or you can make it go to the actual HTML help files that exist on the web, and that's a configuration option. And there is more information if you go to the web than if you just do the textual information that's connected to the command. But you will use your -help options frequently as you learn more and more about the product. Now, when you do the add command in GUI, instead of typing in the add command, you just click on the icon, and when you click on the icon, what it'll do is it will move it from there down to the stage changes, and now we have less files under the unstaged changes and one file under the stage changes. So right now we only have one file that's been added, and that's doing it under the GUI environment. Now, once you've moved something to the stage changes, then you can do a commit. And the commit does the same basic thing as it does in all version control tools. It adds a new version into the repository for whatever changes that have been made. In this case here, we have 4 files that have been added, so we're going to have 4 new insertions into the repository. Now, when you run the commit, it's a good idea, and you can make it so that this is required, that you have a -m and then a commit message or log message associated with it. Here we put in the log message initial commit, and as part of your organization's policies and procedures, you should have rules what the log message should be comprised of, what it should contain. If you have project management, you may have the bug number that you're fixing or the requirement task that you number that you've been assigned, so that people can track your changes back to why you were changing the code. Here we just put initial commit because we're loading the files in the first time. In the GUI tool, you do the commit by selecting the commit button here, and it's going to take all the changes that have been staged and do the commit. So after you've done the commit, you'll notice that your stage changes has been blanked out, because once we've done the commit, there are no changes left to commit. There's nothing in our staged area anymore. Now you get that same result if you ran the status command from command line. After you've done the commit, you get no answers. In other words, when you run the status, it shows you there are no files currently in your working tree that have been staged. And they haven't been staged because, quite frankly, nothing's been changed after you did your commit. Even if you did an add, it wouldn't show you anything because there's no changes. Now you can see differences in files in a number of different ways. Here we're looking at the unstaged changes, and we're seeing what has changed. We haven't staged it yet, but we have modified this file, and we do that by selecting the rescan button, and that scans the file, compares it to what it looked like when it was initially created, and last time it was changed, and here it's showing that we removed one line and added a new line. In other words, we changed a line. This is in the GUI environment. You can get that same information by running the diff command from command line. And once again, we're showing that the old version had test02 for the second line, and now it has test02-new change for the second line. This format here for differences goes back 20 years and is used by virtually all difference engines and version control. Remember, you're only going to see a difference running the difference command like this if this file has been modified. We'll show some other examples of how you can use a difference command later. Now, once we have done a commit, we can look and see what we call our history by running the log command. So we did our commit here. It showed that we made a change. So initially, our first commit just added our 4 files or 3 files in a folder. Our second commit was the fact we changed one particular file. And here we have our different log messages associated with each one of our commits. Now when you do a commit, you have something called a hash. And what these hashes are unique identifiers for each commit, for each change that you've made. And these hashes are used when you want to react or interact, I should say, with a particular commit. And when you type in your hash, you don't actually have to type in the whole thing. You just have to type in enough so that it's unique. And that's usually the first 3 or 4 or 5 characters of a hash. Because remember, the hash uniquely identifies a commit, and it uniquely identifies the person, the machine that the commit was done on, the repository, but you wouldn't have to type in the entire thing for it to be unique. And that's a good thing, because it would be hard to type in whatever number of characters that is. If you're using the GUI tool and you want to look at the history of the repository, you can select this Visualize Master's History, and then you're going to get a GUI interpretation of the history, and you can select either one here. I've selected Initial Commit, and it'll show me what has taken place, what files were involved, and each one of these it was just added, so it'll just show you that each line was added. And there's other information about who the committer was, when it was done, what the branch was, etc. And the log comment is also shown. If you go to the second revision here, it'll show you that we changed one file, test01, and once again it shows you the differences that one file were made in that changing that one file. So that's showing you the same information from a GUI environment. Now we've talked a little bit about this idea of a file being unmodified, modified, and also added to the staged area. And the idea behind this is that files go through various statuses by doing different activities upon them. So a file's unmodified before we change it the first time, but when we edit it, it becomes a modified file. But modified will not be committed until it's been staged. So we would have to use that add command to move it to staged. Well, sometimes there's a reason to unstage a file. And you do that by using the reset command. So up here, for instance, we had the status of, and it's hard to see this, but it's got a green M, and that says that test2 has been staged and modified. But when we ran the reset command on this file, then it's still modified, it's just no longer staged. When we do a commit, it would say that there's no files to be committed because this is now unstaged. Now this idea of some files being staged and other files not being staged might be confusing sometimes, but sometimes you have certain changed files that you want committed at a particular time, maybe because you need to push them to another repository, or you want these staged files when committed to have a particular log message, and then when you stage other files, they would have their own log message. So that's kind of the rationale behind unstaging a file. So let's say you change two files, file 1 and file 2. You accidentally added them both with the git add command, so they're now both staged files. But you wanted each of these files to be committed with a separate log message. Maybe you fixed a particular bug in this one and a different bug in file 2. So what you could do is reset one of the files. Now in this case, only file 2 is staged, and when I run a commit, this log message would only be associated with the file that's going to be committed, which is file 2. Now once that's committed, it's no longer in the staged area. Then we could add file 1 to the staged area and run another git command and have this log message associated with that particular file's history now. So that's one of the reasons why you might unstage a file. Now, one of the most difficult things I found in dealing with Git and making that transition from Subversion to Git was this whole idea of when things are untracked, unmodified, modified, and staged. And the idea is, if I have a file and it's untracked, I haven't decided that it's going to be part of version control yet. Once I say it's part of version control, then before I modify it, it's just considered unmodified, and I couldn't, for instance, do a commit on it. When I edit the file, it's then modified, which allows me then to add the file to our staged area. Once it's in the staged area, I can do a commit, in which case the file now becomes unmodified or classified as unmodified again. And where the file is at any particular time can be confusing, but you can discover that all with that status command. So remember, in your working directory, there's not staged, then there's staged, and then there's whether it's updated the repository or not. The reset command will take your file that's been changed and put it back in the working directory the way it used to look. We can stage files with the add command. Once it's been modified, we can move it to the staged area. We can commit the file to move changes into the repository, and we can do a checkout from the repository to repopulate a working, or to populate a working directory so that we can work on our files. And sometimes that can be a little confusing. Let's show an example now, a lab, of using Git. Now what I've done is I have a folder called test git where I put 3 of our files in a subfolder. And the first thing we're going to do is make sure that we have that folder in existence so that we can modify it. I don't know why this is on. Let's close that. Now I'm going to run git by selecting the git bash here, and I'm going to move this first of all to the location where I want my repository to be created, which is in test git. So the first thing I'm going to actually do is go to test git, and the next step is to go in and create a new repository. And remember, to create a repository, we type in git I should say, and then init, and then it creates a repository. Notice when we create a repository, we get a folder called .git, and there's some information in that folder that relates to the Git product and the fact that this is a repository. Once you're in a repository, it will as long as you're in this folder, it knows you're using this particular repository. Now at this point, I could type the git status command, and it would show me that there are untracked files. The files that were in this now working area were not added yet to our repository, so it comes in as untracked. If I ran the same command in short form by typing the option -s, it would show the question marks here to the left of the folder and the files to show they're untracked. So the first thing I'm probably going to do, and it tells us, for instance up here, use the git add command to include these files. So I'm going to go in and put in git add, and it noticed that I did something wrong. I didn't specify a file, neither did I put a period at the end to say to take the whole directory, and it points at that out as an error message. It doesn't actually tell you anything when it does the add command, but if I run the status command again, notice that these are statuses changed from question marks to A's, and now if I did a commit, it would allow me to do the commit and it would add these files to the repository. So I'm going to do a commit now. I'm going to say git commit. I'm going to put in -m for my log message, and I'm just going to say initial load. And it's telling me the 4 files are changed. There's been 4 insertions, and now if I run my status, notice it shows nothing because there are no new files, there's no changed files. It's in the repository. Now the next thing I'm going to do is modify a file. So I'm going to use the VI program, and I'm going to modify test01. And I'm going to put here and then I'm going to save it. Now if I run my status command, it shows there's 1 file. Notice the M is in the second column here and it's red instead of in the first column in green. What that says is the file's been modified, but it hasn't been moved to the staging area yet. It hasn't been added to the staging area. If I tried to do a commit now, there'd be nothing to commit. If I do the add command now, oops, and once again I could put in test01 here, or just the dot. Now this would be moved to the staging area. And if I run the status command now, notice that the M is now in the first column and is green instead of the second column and is red. If I now run the commit, it'll update that 1 file. And if I now run the log command, we can see our history. And we have 2 commits, that one for my initial load and the one from changing 1 file. Now there's lots of different ways to run the log command and have this be formatted in many different ways. One of the ways I use a lot is name only. So I'm going to run git log, but I'm going to put -- name only, and then that will show me the names of the files that were modified for each one of these commits. So in the first commit we had folder and a file and 3 files. The second one we had just a single file that was modified. So that's basically how easy it is to create a new repository, to add files to that repository, to commit those files to the repository, to change one of those files, and they add that change to the repository and use the log command to see what has changed. Let's go back and talk now about branching. Now, in branching in Git, there's three main commands that you use at the lowest level, the introductory level. One is the branch command, which will tell you which branches exist and which one you're currently attached to, which one you're currently working with. The checkout command with a -b option to create a new branch, and the checkout command with an existing branch's name to switch to that branch. Now, the reason you would have multiple branches is because you're working on multiple tasks in the same repository at the same time. Let's say you had two different bugs to fix. Well, you may create separate branches to fix those bugs in, and then once you fix those bugs, you may merge those changes back into your master branch, and then the master branch is what you would at some point transmit to a remote repository. So let's look at a little example of doing branches. So by default, you're starting out in the master branch, and you may not have any other branches. So I have a file called numbers.txt, and I have added that to my working directory. And if I did a status, right now we haven't said we want it under version control, so you get the 2 question marks. If I added it to version control, and say I wanted it added to version control, it would move to the staging area, and if we did our status, we get our green A. When I do a commit of the things in the staging area, this one file will be added, and the repository will be updated. We will have a new version in history, and if I did a status at that point, we show nothing because it's all been moved to the repository. So at this point, we have our file and we have our new version, and if I did git branch, it will show that we only have one branch called the master branch. The asterisk says that is the branch we're currently using. Now the next thing I might do is do a checkout with the -b option and create a new branch. And I'm going to call that branch bug123. And when you do that, you will switch to that particular branch. So the repository is going to take my latest copy of numbers.txt and move it to the working directory for this branch. Then I might use my editor and modify that. Before I modify it, there is no change because this hasn't been modified. Once I've modified it, and if I run the status command, it shows that it's been modified, but it's still in the working directory. When I move it to the staging area, it gets a green M instead of a red M. When I say moving to the staging area, nothing actually moves. It's just reclassified as a file in the staging area instead of not in the staging area. So this is where it's changed initially. Once I do my add, then this is where it is in the staging area. And you can have the same file be changed not in the staging area and be changed in the staging area. So I went back and changed it again. I would have a green M and a red M for the same file. If I did a commit, it would only take the changes that have been moved to the staging area and not the changes I made later before or after my initial add. So, oops, went to. So I made my changes, I moved to the staging area, I do a commit now. When you do a commit, it shows you which branch you're doing that commit to. In this case, since I'm in bug123 branch, it's going to show us that that's where the repository is updated. I do a status after my commit, of course I show nothing here. So where we are now is I've created this branch and now I've made a change. So I'm going to make all my changes in that branch. Now, if I want to go back to the master branch and modify files, I would do a checkout with the master branch. The -F option says, even though the changes in the working directory, because I made changes when I was working on bug 123, I want to have those changes ignored and overwritten with the last copy of the file that was in the master branch. So by doing the checkout now, I will now be on the master branch. If I did the get branch command, it shows that I have 2 branches, but I'm now on the master branch, where before I did the checkout, it would show there's 2 branches, but I was on the bug 123 branch. So you can always check to see what branch you're working on. And of course you want to make sure you're working on the right branch for whatever task you're doing. Now at this point, the numbers.txt has been forced back to the way it looked like when I was last working on the master branch. So I might go through and change the master branch, use my editor, and replace numeric 2 and numeric 4 with textual versions of those 2 lines. Once again, it's in the working directory. Now I can go through and do a commit without doing an add by having the -AM option and then putting in my log message. The -A sort of does an add and then allows you to do the commit at the same time. And so I'm going to do a commit now, and now I will update the repository with those changes. And when I say I'm updating the repository, I'm updating the master branch in the repository. -A is the same as running the add command before I do the commit. It does it in one step. So where we are now, we've had a change in bug 123 branch, a change in the master, and at this point you may merge those changes together. Because you may be working on many different branches and fixing different bugs, and at some point you're probably going to have them all merged into the master so you can transmit it to somebody else. When we merge them, it's going to take these changes, move them in with these changes, and give you one file, which may or may not have a conflict depending on what changes you made. So here's our file in bug 123. Here's our file in the master branch. When I did a merge, it tells me that I have a conflict. Now the reason you get conflicts is when it can't necessarily take the changes from one place and incorporate them in the second place. And the reason it couldn't do that here is it didn't know where this 4 should be, whether it should be above or below this new line 3 here. Because even though we think we're replacing the 4 with a 4 and the 3 with a 3 equals THREE, to the system these are just lines, and if it can't find the exact same before and after line, it doesn't exactly know where to insert them, in which case it's going to give you an error. This format here, what we call conflict pointers, has also been used for almost 30 years by difference programs and version control programs. And what it's saying is, in the master program, the latest revision, we have these changes. In the bug 123 we have these changes, and somebody has to resolve the conflicts. Now the way that you actually resolve the conflicts would depend on what kind of code you're writing and why there is a conflict there in the first place. Now in our example, we're going to say that the resolution of the conflict is to take line 3 equals 3 and the TWO and the FOUR, and that becomes our 5 lines. We've now resolved the conflict, and then we would commit that into the master. We're in the master branch, and that's where the commit would take place. If you run a status, it will show you that the file has been modified and that we did that to fix comments, and then we would run our commit after we've staged that, and it would update our repository. Once we have done our commit, if we run the log command, it would show us another revision here where we did the merge and our previous revisions. The way the branch, which is bug 123, and the master show up here, and how that merge happened is shown graphically. Here is the master up to here and up to that version. This bug 123 is that particular revision, and when those two are combined, that would be what was put into the master with the log message of merged with bug 123. So that's just showing you what it looks like in the GUI environment. Now the status command you're going to use a lot, so we're going to talk about some different ways you can use it and what it will show. In this example here, we're getting two M's, a green one on the first column and a red one on the second column, because after we staged the file, we went back and modified it another time, and so we have a version of it that's modified and not staged, a version of the file that's staged, and a version that was last put in the repository. Now we can use the difference command to examine how these files are different. When you run the verbose version of the status command, it would show you that it's both been modified and in the staged area because it's ready to be committed, and it's been modified afterwards but not staged yet. So that's the red version, that's the green version, and this is the last version in the repository. So when I use a difference command, depending on how I use it, I would see different differences. For instance, here it's showing us, when I run the diff, of what happened to go from after, in other words, we changed the modified after we did the stages, so it's as if we're going from the stage to get back to modified. What would I have to do? And it's lines 8 and 9 are removed, and line 9 NINE-9 has been added, and that's what it's showing us here. If you don't like the way this particular diff program works, in the configuration options you can set other either paid or open source diff programs to be initiated when you run the diff command. If I do a diff against cached, it will show you the difference between the version of the file that's staged and the last version, in other words, where this started in the repository. And the difference between these two is this one has lines 6, 7, 8, 9. See the plus 6, plus 7, plus 8, and plus 9 added to the file. And lastly, I can compare the last version in the repository with the latest version that's been modified, and I'll show you the difference between the repository and the modified, where I've added line 6, line 7, and line plus 9-9 here. So you can look at different comparisons between the modified, the staged, and what was last in the repository. I'm going to take a second here and give you a little demo of doing our merge. So let's go to here. The first thing we're going to do is create a branch. Now notice that when you're looking in the Git Bash here, it shows you what branch you're in because it says master. So our first, excuse me, our first command is going to be to create a branch. So I'm going to say git branch -b, and the name of my branch, which I'm going to call bug 654. See if I type this correctly. Oops, I didn't. I'm sorry. I'm used to using other tools. It's called checkout. But I did that just so you could see what the error message would look like. And what it's doing, it's creating a branch and it's transferring me to that branch. Now I'm in bug 654. Now I'm going to go and modify a file. And I'm going to say that this is a new change in branch 654, bug 654, and then I'm going to save this, and then I'm going to run the git add command so that I can move this to staged. Oops. I type get often. And if I ran my git status, now it would show that there's one ready to be committed, and then I can run the commit command, git and I'll say that it's in the branch, and it did that. Now I'm going to switch to the master branch and make a change there before I do my merge. And the way I switch is the git checkout, and then you specify what you want to, how you want to do your checkout, and I'm going to put -F to remove any local changes, and then you specify where you want to move to, which is the master branch. And now notice that this here has changed to master from the branch I was on. Now if I make a change, I'm going to go VI test 101. Notice that there's nothing here about branches because it went back to the version that was in the master branch last time I was in the master branch. And I'm going to now just go and add here. Oops. And I'm just going to newer. And then I'm going to save that. And then this time I'm going to do a commit and put A, so it'll do the add automatically for me, and put added change to master here. And it's done mine. Now I have basically 2 branches, and I made a change in each one of them, and this is what I might do a merge. Now you go to the branch you want to merge into. I'm already at the master, so I would now go in and I would do the merge command, and I would specify what branch I want to merge into where I am now, which is the master, and that is bug 654. Oops, without the space there. And now I'm going to do the merge. It comes back and tells me that I have a conflict. Now if I look at the file that's in conflict, I will have those conflict pointers, and notice that the reason the conflicts happen here is on that third line that says test 02. I changed that both in the branch and in the master, and the system can't tell which one's right and which one's wrong. Maybe it turns out I want both of those lines there, so I would do, oops, this might be my resolving of my conflict. Oops, escape, shift. And now I can do my commit again. Resolved conflict. Notice that I have my -A because I'm going to do my add and commit at the same time. And now if I do my git log command, it'll show my initial changes in the master and then that resolved conflict that I have done. So let's go back to this. In conclusion, what WANdisco is doing at this point is offering Git support in the same way we have support for Subversion with a global team of experienced and talented technical engineers. We also have support for Git. and it's available 24 hours a day, 7 days a week, and the support can be by phone or email, and we support that support to our customers, which includes a case tracking system, a comprehensive knowledge base, access to software service packs, patches, and documentation, and a step-by-step troubleshooting and direct access to support specialists. So the same sort of support that you can get in Subversion, it's now available for people who are using Git. Now, before we talk about the upcoming webinars, we've taken some questions that have been emailed, and we're going to answer a couple of them.
Perfect. Thanks, Mike. So if I take a look here, we have a lot of great questions. First one is here, can I get Git to ignore certain files so they don't get added by accident?
Yes, this is works kind of the same way as it does in other tools. There's a number of different places where you can put a list of file types that you don't want to be considered as that they should be added to version control. In almost every development environment, as part of your testing and compiling, you're going to have these temporary files added that you normally don't want added to version control. For instance, like the exe file that's the outcome of doing your compile, you normally don't want that in version control. And there's a couple of ways to do this. There is a, you can create a file called .gitignore_global and put that in your home directory, or as part of your Git configuration, there's a variable called excludes file. It's actually called core.excludes file that you can point to any file in any location, and then in that file basically specify the types of files that you want to be ignored. So you might have star.exe, for instance, or star.obj. Next question.
Perfect. How do you keep binaries out of our Git depot, or Git repo, sorry?
Yes, a lot of people don't want to put binary files in the repository because they, in some cases, get changed a lot, and they're very large, and they can make your repository, when you do checkouts or establishing new local repositories, very slow. And what you can do is there's hook scripts, or ability to define hook scripts. There's one called pre-receive, and you can just exclude whatever binary files such as star.jar or star.tar from being pushed into the repository. Another way of doing the same thing is just examine the size of the files, and then don't let really large files, which tend to be these binary files, be added to the repository. Oops, we better hurry. More questions?
Yep, a couple more. Where should we keep settings that specify our Git repo policies?
Okay, you're going to have a configuration file per repository, and you can look at what's in that configuration file with the git space config command, and that's where you should do those things that are going to define your repository policies. But the first thing, of course, is to decide what your repository policies should be. When you're operating Git with a group of people in different locations, you're going to have a lot of policies and procedures as far as how things are moved from the local repositories to the group server repositories. And once you decide that, then you can enforce those through doing things in your configuration files. Do we have time for one more?
Yep, let's just take one more. I have heard about rebasing. Why would I do that on my local repository?
Okay, what they mean by rebasing, and we'll cover this in later webinars probably, is when you have a number of revisions that have been committed to accomplish a particular task. You may actually do commits every hour, every half hour, whatever, but then when you finish whatever the task is, rather than having all of those changes sent to another repository, By rebasing, it'll in effect take the number of different changes and move it all to one revision so that people don't have to see the individual changes, they just see the results. That's called rebasing. And that is done locally for things that haven't been published so that you can only publish the latest revision. And it's all done to make it more understandable when people are looking at what you've changed in that remote repository. Instead of seeing 10 changes, they'll just see the outcome of those 10 changes. And it's important that you modify your log message to reflect and make sure you have all the information you want in that log message. Okay, we're pretty much out of time. We do have some upcoming webinars. This is on the Subversion product. We have on June 20th one on hook scripts, and then on July 11th we have one on advanced hook scripts. So we're going to give more information about different ways you can use hook scripts. And all of this information can be looked at by looking at this URL at the bottom. You can look at the webinars that are coming up. Jen, do you have anything else to say about things coming up?
Yeah, great. Thank you, Mike. That's all we have time to answer today. We want to thank you for your submissions. Don't worry if your question wasn't answered. It will be answered over email. Please visit our website, www.WANdisco.com, to sign up for additional training like today's Intro to Git. You don't want to miss our June 12th webinar, Selecting the Right SCM Tool for Global Software Development. Thank you again for attending, and have a nice day.